Greetings, internet using individual. Welcome to Talk Nerdy School, where we put the cool in school. Today, we are going to be going over some really interesting limits that can be pretty tough to wrap your head around at first, but we'll get through this together, I'm sure. The first limit I would like to talk about is the sine of x divided by x as x approaches 0. If we simply plug 0 in for x like we normally would, we get 0 divided by 0, which is undefined. But if we take a look at this on a graph, we can see that the limit clearly approaches 1. So if we want to, we could just stop and say the limit as x approaches 0 of sine x over x is equal to 1. But let's work out why this is mathematically, because that sounds like a lot more fun to me. I don't know about you. Okay, so in order to think about this, we need to take a step back to trig. So let's bring back our old friend, the unit circle. Now, if we draw an angle on this circle that we'll just call theta, we can start by making a triangle in this little region here. And the height of this triangle is sine theta, right? From trig. You guys should remember this. Then the area of the triangle will just be 1/2 sine theta, or sine theta over 2. Then we can look at the sector of the circle that we are in. And the area of this is proportional to theta. So the area of the unit circle is pi. Our angle is theta over 2 pi, so the area of our sector is simply theta divided by 2. Now we can make a third triangle whose height is tangent theta, and the area of that triangle is tangent theta over 2. So we compare these three, and we can see that sine theta over 2 is less than theta over 2 is less than tangent theta over 2. So this is going to be really important as we go through and try to evaluate our limit, which we'll get to in just a second. Okay, let's bring this back around. Now we've already set up our inequality, but it looks a little messy right now, and it doesn't look anything like sine x over x or sine theta over theta. So let's try to get it somewhere to look like that. Start off by just getting rid of that division by 2. I'm not a fan, you're not a fan. Let's just multiply everything by 2 and get rid of it. And then we can go back to our lovely friend trigonometry and remember that tangent of theta is equal to sine theta over cosine theta. So we can replace tan theta with sine theta over cosine theta. And now we can divide every term in this inequality by sine theta, which gives us 1 is less than sine theta, or theta over sine theta is less than 1 over cosine theta. Then we take the reciprocal of every term. So we get 1 is less than sine theta over theta is less than cosine theta. So now we've got something that looks a little bit more like what we were trying to take the limit of in the first place. So let's go ahead and take the limit at this point. Now we can see that the left-hand term will just be 1, and the limit as theta approaches 0 for cosine theta is also equal to 1. And the limit as theta approaches 0 for sine theta over theta is sandwiched in between the two. Therefore, the limit as theta approaches 0 of sine theta over theta is equal to 1. I could cry at how beautiful this is. This is fantastic. Now remember going forward that you just need to know the limit of sine theta over theta as theta approaches 0 is equal to 1, but this is why that happens. Okay, it is time for another limit. Let's take a look at the limit of 1 minus cosine x over x as x approaches 0. If we plug in 0, we're going to run into the same problem we had before. We get 0 divided by 0, which is undefined. We can't do it. And if we take a look at our graph, we can clearly see that the limit must approach 0. But why is that? I think you guys know what time it is. Let's go do some math. Okay, so if we take 1 minus cosine x over x and multiply both the numerator and the denominator by the conjugate 1 plus cosine x, what we are left with is 1 minus cosine squared x on top divided by x times 1 plus cosine x on the bottom. Now remember your trig identities, 1 minus cosine squared x is simply equal to sine squared x. So we can go ahead and replace our numerator with just sine squared x. Now we can just split this up and say that sine squared x is equal to sine x times sine x. Now, this is where we get a little bit interesting because we already know that the limit of sine x over x is equal to 1. So let's go ahead and just put that in there, right? Then if we look at the right-hand term there, the limit of sine x is equal to 0. 1 plus cosine x as x approaches 0 is going to be 2. So we get 1 times 0 divided by 2, which is equal to 0. So we did it. Huzzah! We are done with limits for the day, I think. Okay. Now that your brain has grown sufficiently, let's take a quick pit stop and recap. In this video, we discussed two very interesting limits, the sine of x over x and 1 minus cosine x over x as x approaches 0. And we understand that the limit as x approaches 0 of sine x over x is equal to 1. The limit as x approaches 0 of 1 minus cosine x over x is equal to 0. Knowing this will be important later on when we try to use limits for some even cooler math. Alright, I hope you found this useful, and I wish you the best of luck as you continue your journey into this fantastic world of calculus. If you enjoyed the video, learned anything, or just had fun, don't forget to like, comment, and subscribe. And remember, never stop learning. This is Talk Nerdy School, and I think I've reached my limit, so I'll see you next time.